This is an Algebra 1 class. Today we're going to be looking at special factoring when we have a perfect square trinomial or a difference of two squares. So as we begin to factor, we know how to factor a trinomial, but we have special situation here where our first term of our trinomial is a perfect square, and so is our last term. The middle term is going to be the sum of our outer and inner. Let's see how that works. First off, let's factor like we usually do. We set up a square. And above our first column is our first term of x squared. Above our second column is our last term of 4. And our goal in the middle is to get a negative 4x, so it goes over here. Since these are perfect squares, our factors that we're going to use to multiply to get x squared are both identical, x and x. We're going to do the same thing for our factors to multiply to get 4. It's a perfect square. It's either 2 squared to get 4, or it's negative 2 squared to get 4. In this case, since I need a negative in the middle term, I'm going to have to use negative factors. So I'm going to use 2 factors of negative 2. When I check the factoring, notice as I multiply across x times negative 2 to get negative 2x, it's the same factor in both places, x times negative 2, which is negative 2x, and those add up to negative 4x. Notice that these two are the same. There's 2 of them. We could think of them as being 2 of negative 2x, which gets us the negative 4x. And our negative 2x comes when we multiply the square root of x squared, that is x, times the square root, the negative square root in this case of 4, which is negative 2. So now let's take a look and see how this factors. We end up here with our factors going diagonal. They go across. So we have 2 factors of x minus 2, or we can combine them and write it as x minus 2 quantity squared. So when factoring a perfect square trinomial, we always end up with 2 of the same binomial. In fact, it's that binomial squared. Let's see if we can do another one on here. Let's go ahead and do it with the square once more, and then we'll see if we can do them without the square. So as we look at our square, our first term, 4x squared, our last term of 9, and our goal to get a middle term of 12x. We're going to look for what multiplies by itself to get 4x squared. So 2 identical factors of 2x. 2x times 2x gives us 4x squared. And with 9, this time we are going to use the positive factors because I want a positive middle term. So the 2 factors that multiply to get 9 identical factors are 3 and 3. Again, notice that these 2 are exactly the same. So 2x times 3 is 6x, and another 6x. We have 2 of 6x to get 12x. Our 2 factors, again, are identical. So we have 2 factors of 2x plus 3, which gives us 2x plus 3 quantity squared. Now let's take a look at this factor for just a moment. Our first term, our 2x, is what we square to get 4x squared. Our last term in the binomial is what we multiply or square to get 9. So we can always, when we have that perfect square trinomial, break it down to this binomial squared. What we do need to make sure is that our outer and inner terms add up to the correct inner term here. Okay, let's take a look at number 3. Number 3 doesn't look like it's a perfect square trinomial. We have a negative term to start with, and 2 is not a perfect square. However, as I look at these terms, I see that each one of these terms in a trinomial have a common factor of negative 2. So we're going to start by taking out the common factor of negative 2. We always look for a common factor first when factoring. So dividing out or factoring out a negative 2 leaves us with x squared minus 10x plus 25. Now as I look at the resulting trinomial, the first term is a perfect square. The last term is a perfect square. It's 5 squared or negative 5 squared. So we can factor this very quickly into two binomials without using the square. X squared is x times x. 25 is 5 times 5. Both of them need to be negative so that I can get a negative in the middle. Notice that these two binomials are identical. Just a quick check of our outer and inner term. Our outer term is negative 5x. Our inner term is also negative 5x. Two identical terms to get negative 10x. So we have negative 2 times x minus 5 quantity squared. Okay. Our next example has two variables in it, but it works the same way. Our first term is a perfect square, x times x. Our last term is a perfect square, y times y. And the middle term here is 2 times x times y. So it fits the pattern exactly. Let's write it out so we can see. We have x times x for x squared and y times y for y squared. When we do the outer and inner term, notice xy and another xy, which gives us 2 xy's. This trinomial right here gives us our pattern so that we can see that factoring a trinomial, a perfect square trinomial, gives us the binomial x plus y quantity squared, as long as the middle term is 2 times x times y. Let's take a look at a difference of two squares. The difference of two squares is not a trinomial, it's a binomial. And it's basically the first term and the last term, where the middle term is missing. It adds up to 0. We can think of this as being y squared plus 0y minus 16. Our outer and inner terms are going to add to 0. So if our outer and inner terms have to add to 0, well, let's put it in a square and let's see how that looks. Our first term is y squared, our last term is negative 16, and our missing middle term is 0. That means I want these two factors that I'm going to get to multiply or to add up to 0. So let's do that. Perfect squares again. Y squared is y times y. 16 is a perfect square, but since it's negative, one of the factors is going to be negative. So 16 is 4 times 4. Let's make one factor negative, one factor positive. We multiply across, we get negative 4y and positive 4y. Notice that these are opposites of each other. They're opposites because these factors are opposites of each other, and they add to 0. That is, we will not have a middle term. So our factors, again, going diagonal, we end up with y plus 4 and y minus 4. Notice that these two factors are identical with the exception one has a plus and the other has the minus. Okay, let's do that again. Number 6, again, we have a difference of two squares. 25 is the perfect square 5 squared. And x squared is, of course, x times x. So let's put it in a box. First term, last term, and our middle term again is 0 because it's missing. The perfect square for 25, 5 times 5. The perfect square for negative x squared, because it's negative, I have one positive and one negative. So I'm going to have a negative x and a positive x. When I multiply across, the two products, the outer and inner products, are opposites and they add to 0. So our two factors are going to be 5 plus x and 5 minus x. Again, identical, except for one is plus and the other's minus. Let's do another couple of examples. On this one, we look at it and we say, gosh, 5 is not a perfect square. But we also notice that 5 will divide into 125 as well as into 5. We have a common factor. So common factor always comes out first. 5x squared divided by 5 is x squared. 125 divided by 5 is 25. So we have x squared minus 25. This then is a difference of 2 squared. Our outer and inner term is 0. So I know my two binomials are going to be identical, except 1 plus and 1 minus. Our perfect square, x squared is x times x. 25 is 5 times 5, and I want negative, so 1 negative 5 and 1 positive 5. And that's factored, a difference of 2 squares. The outer term of 5x and the inner term of negative 5x add to 0. Number 8, as we look at that, we have a coefficient of 9 and a 100. These two don't have a common factor, but I look at those and I go, gosh, this is a perfect square. 9x squared would be the perfect square 3x quantity squared, and 100 would be 10. So I have two perfect squares. It's a difference, it's a subtraction in the middle. So our two factors, again, identical, 1 plus, 1 minus. So 3x minus the 10y and 3x plus the 10y. Again, our outer term, 30xy, and our inner term, negative 30xy, add up to 0. So that's factoring with special products.